Good afternoon, everyone. So, as you all know, this week in Paris, the world political leaders are meeting to find solutions to one of the biggest problems that Earth is facing right now, climate change. So, one of their main aims to keep the global warming below 2 degrees Celsius. How did they get this number? That's the part of scientists comes. So someone has to do experiments, take measurements for a long period of time and analyze those data for them to make predictions and make decisions for us. So in our group, Purple Crow LiDAR team, we measure atmospheric water vapor. You may ask why you need to measure atmospheric water vapor. I would say 95% of the global warming is happening due to water vapor in the atmosphere. And that makes water vapor the most dominant greenhouse gas. And together with other greenhouse gases, water vapor keeps the Earth's average temperature around 15 degrees Celsius. If we don't have water vapor, that will be around minus 10 degrees Celsius, like winter every day. So how do we measure water vapor in the atmosphere? It's really challenging because the water vapor is really variable. So the most vastly used method is the radio sondes, but the sondes fail taking accurate measurements in higher altitude. So we use light detection and ranging technique that we call LiDAR technique. So a typical LiDAR system consists of a transmitter, which is a laser, and a receiving system with a telescope and set of detectors. So what we do is we send a laser beam vertically to the atmosphere. So beam goes high in the altitude and start to collide with water vapor, dust, and all sorts of air molecules. Once the beam hits with a particle, the light start to scatter. So using our telescope, we collect all the backscattered light, and a set of detectors help to differentiate the energies of the backscattered light. So analyzing those measurements, we could say this is the amount of water vapor in the atmosphere. So we figured out 50% of the atmospheric water vapor is located below 2 kilometers from ground. Not only that, we can also use these water vapor measurements to detect the changes and trends of atmospheric water vapor in long period, and also to develop and test the atmospheric models, and finally, to understand the impacts of global warming and climate change. Thank you.